Hello everyone, let's look at the next type of code, that is RS code. In case of the RS code, the first question arises that why it is to be called as RS code. If you try to recall, in earlier case what we discussed is the BCH code. Now, BCH means it is the Bose, Chaudhary and Hem code. The same way this code is named with read, that is R for read, S for Solomon. To read Solomon code. It is simply the name of the scientist, nothing else. The format is different. This time we are going to concentrate on the non-binary cyclic code. Earlier we have seen that BCH is nothing but the binary cyclic code. But here the RS code is nothing but the non-binary cyclic code. Now as it simplifies, it is non-binary. It means that it is having the coefficient not only in terms of the zeros and ones but also in terms of the alpha. So at the critical cases, it is mostly dealt up with the alpha, means the values of coefficients will be in terms of the alpha this time. And the very important thing is that m bit sequences mean each symbol from this RS code will have the m bit sequences. So these sequences, how to get the sequences, that we will see. And importantly is value of m, means number of bits in each symbol will be greater than 2. For n as well as k, for n and k RS code, it is quite desired to get the m bit sequences. Now n means, as we have seen in the earlier cases, that is it is nothing but the number of code bits or the number of code vectors. But this time the n is been called as a number of code symbols. Similarly, k is nothing but the number of data symbols. But to get the number of parity, that is n minus k symbols, that is the parity symbols, we need to get this particular expression, that is twice 2tc. So in case of the BCH, we have seen this is mtc. So firstly we need to obtain m and then we will be able to obtain n minus k. Right now here, in case of the RS code, it is desired to get the again tc based on n as well as k. Now we will see what exactly the format for the RS code. It is again with the format, that is n is equal to 2 raised to m minus 1. Replace 2 raised to m with the q, because sometimes in the book you may find that the field of q is nothing but actually replaced by this 2 raised to m. So gf of q or gf of 2 raised to m. So q minus 1 minus 2 tc, again it will give the value of k. Ultimately, n minus k is nothing but the number of parity symbols. Since all these are nothing but actually the subclasses of LBC, that's why the same equation which we used to follow for the LBC, it is as it is used here also. So d min will be given by the expression 2tc plus 1. Now let's look at how to go for the encoding in case of the RS codes. As we have seen, before proceeding to the encoding of RS, let's revise what exactly the encoding steps for the BCH. In case of the BCH encoding, we have seen the g of x is obtained with the LCM of phi 1, phi 2, phi 3 up to phi 2 TC. What is phi here? Phi was nothing but the minimal polynomial. Okay. Similarly, if we go for the odd number of polynomials, minimal polynomials, so obviously expression was given like g of x equal to LCM of phi 1, phi 3, phi 5 up to phi 2 tc minus 1. In the same way, we can obtain it for the various values of the tc, that is the correcting capability of the code. Now let's look at here what is RS encoding, how to proceed for it. So RS encoding, this is what the format of RS code. This is what the n minus k expression. This expression is nothing but the expression for g of x. So g of x is generalized with this expression that is g0 plus g1x plus g2x square up to x raised to 2tc. Since it is a subset of DCH, therefore it does have roots as alpha square up to alpha raised to 2tc. So ultimately, if it is the roots, all these are the roots of g of x. So this expression will be valid, that is g of x is equal to x plus alpha into x plus alpha square up to x plus alpha raised to 2tc. So once we got the g of x, next case is quite easier to understand, means just try to recall the cyclic code concept. In case of the systematic cyclic code, we used to obtain it by using two formats. Means once we got g of x, for the non-systematic it will be g of x is equal to d of c of x is equal to d of x into g of x. And for the systematic, it is nothing but c of x, that is the code polynomial or the code word, can be given as x raised to n minus k dx plus p of x, where p of x is nothing but the remainder polynomial, which can be obtained by x raised to n minus k dx by g of x. Now, in the same way, let's proceed with one of the design expressions and how to get or how to solve rather the problems based on the RS encoding. So when it is asked to just find out code word, then it is up to the user that which kind of technique he will have to use, either systematic or the non-systematic. If it is really specified in the statement that it is systematic, then proceed with the same technique. Let's look at one of the example of RS encoding. Okay, this is what the example of RS encoding. This is what the statement that design 15,11 RS code. Find code whose message polynomial is x plus 1. Message polynomial means d of x is given. It is asked to find out c of x. D of x is given. Now the task is we need to obtain the c of x. G of x we need to obtain. Then only either with the systematic or non-systematic approach we can obtain c of x. Now in the statement it is not mentioned whether to go for finding the code with systematic nature or non-systematic. So that's why we will proceed for this with the non-systematic approach. Okay, so let's proceed. Here 15 is nothing but the value of n, 11 is nothing but the value of k. So 15 minus 11, that will give tc. It means 4 is equal to 2tc. So tc will be equal to 2. Next is g of x is equal to, based on tc equal to 2, the expression will be x plus alpha into x plus alpha square into x plus alpha raised to 3. This is incremented by 1. Remember, it is not 1, 2, 4 likewise. Okay, it is 1, 2, 3 and then up to 2tc. That's why it is coming here x plus alpha raised to 4. Now once we got this expression, now the question comes, if let's say at certain time I need to obtain alpha into alpha square into alpha cube, it means ultimately it is alpha raised to 6. What should be the value of alpha raised to 6? I need to refer. Then this value must be referred from Galois field of 16. Why? Because value of m, which can be obtained with the expression log n plus 1 to the base 2. That's why it is coming here m equal to 4. And we need to refer the table, Galois field of 16 table, to solve any of the simplicity related to the alpha. Now, once we multiply all these terms, then we will get the value of g of x like this: alpha raised to 10, alpha cube x plus alpha raised to 6x square plus alpha raised to 13x cube plus x raised to 4. Here you can just means observe the effect that why it is non-binary cyclic code. So here it is nothing but the alpha raised to 10 means x raised to 0 will have the coefficient alpha raised to 10. X is having the coefficient alpha cube. X raised to 4 will have the coefficient 1. It means that coefficients are not only 0 or 1, but it is in terms of the alpha. So that's why it is called as a non-binary cyclic code. Now d of x is given to us. We know the g of x. With the help of the non-systematic cyclic code approach, we can obtain c of x, that is d of x into g of x. By multiplying these two terms, obviously we will get this particular c of x. If it is asked in the problem statement that go for the systematic cyclic code, then it is our responsibility to go for calculation of c of x in terms of the systematic approach only. Okay. Now from the c of x, it is nothing but the polynomial. We can obtain the c. So to get the c from the c of x, let's proceed with the coefficient to be written over here. That will give the nature of, you can say, the code word related to the c of x. So this is alpha raised to 10, this is alpha raised to 12 respectively. After x raised to 5, we are not having any faithful term. So that's why we are writing here further zeros. But how many total number of terms will be this one? It will be total 15. That is what? N equal to 15. So code length, or this time the number of symbols, will be 15. But the question again arises over here. If n equal to 15, for each symbol we need to represent it with the n minus k parity symbols. So let's see here what exactly it is. Means how the alpha raised to 10 will be represented in 4 bits. So it will be on the next slide. So by the reference of the Galois field of 16 table, since m is equal to 4, alpha raised to 10 from the table will be alpha square plus alpha plus 1. It means it is 0 triple 1. Okay, means for alpha cube we are writing it as a 0, rest will be 1. Here is cube, square, 1 and 0. That's why it is 4 ones for alpha raised to 12. Likewise, it is been written for all the values. So whatever we have seen over here for earlier slide, alpha raised to 10, it will be replaced by the number of bits, 4 bits, that is 0 triple 1. Alpha raised to 12 will be by 4 ones. So in this way actually it will be the code for the RS. So in short, it is nothing but the RS encoding. So that is what one of the reason that rate of transmission for RS is greater than the BCH, because ultimately for each symbol we are transmitting 4 bits. Although dmin is equal to 5 for both cases, if we just compare it with the BCH, still we will get the same kind of conclusion. Now let's look at for the next example, which is again on the RS. This has been specified with the generator polynomial of triple error correcting code. Means TC is equal to 3. So if TC is equal to 3, ultimately g of x will be x plus alpha, alpha square, alpha cube, alpha raised to 4, alpha raised to 5 and alpha raised to 6. By multiplying all these terms and with the reference of which table this time? With the reference of, since it is provided in the problem statement, that is the g of 2 raised to 4. So 16 table. Again we will get the values of g of x. But here the thing is, what exactly the values of n and k? Although it is not provided in the problem statement that the n is this one, k is this one, but just try to refer the properties of Galois field, where highest degree term of g of x, that is 6. It is nothing but the n minus k. So n minus k is equal to 6. From this, just refer the earlier equation, k is equal to q minus 1 minus 2 tc. Q is nothing but what? 2 raised to m. So for our case, it is been written like this. So q for this one will become the 16. So it is giving ultimately the value of k as a 9. So this particular code, when we solve it, we can able to justify that it is nothing but 15 comma 9 RS code. That is what the ultimately the RS encoding means. In the next lecture we will see what exactly the RS decoding. Thank you everyone.